Hello, it's
Homework time.
homework time. All right, so tonight you are going to complete this side of the test review. There are 1, 2, 3, 4, 5, like 6 questions because we have a part A and a part B. All right, so we did the first sheet numbers 1 through 8 in class today, and you have that with you. So review that.
At this time, all students of bus 5 cannot report to the fish tank. At this time, all students of bus 5 cannot report to the fish tank.
And now we're going to do the second half. So be sure to review sheet number 1 as well, okay? All right, let's get going. This is a tricky one. Okay? But we're going to do it. So, listen. Allie has 4/6 of a rectangular pizza. She cuts each piece in half. Shade the visual model to show how much of the whole pizza Allie has. So what we have to do is we have to compare the fractions and find a missing piece. So we have 4/6, and we're going to create 2 equivalent fractions. So I got my 4/6 from here. Then this is a picture of after she cut each piece in half.
Now here. Bus
Okay?
5 is now here.
So let's count how many pieces are in this visual. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces. That represents our whole. So we're going to put 4/6, and then we're going to make another fraction, and we're going to put 12 in the denominator, the bottom, representing the whole. And we have to figure out how many pieces we want to shade, okay, in the pizza after she cut each slice in half. So we did this before. What we have to do is we have to ask ourselves, or we can actually just cross multiply. Yeah, let's do that. We can say how many times does 6 go into 12? 6, 12, 2 times. So we multiplied 6 times 2, and then we can multiply 4 times 2, or we can do cross multiplication. So 12 times 4. What's 12 times 4? Dun, dun, dun. 48.
Wait.
You will have the picture up. But if you skip count by 4s, remember, if you don't know your 12s, the commutative property means you can skip count either way. So you could skip count by 4s 12 times. So we go 4, 8, 12, 16, 20, 24, 32, 36, 4. Wait, did I mess that up?
Yes.
4, 8, 12, 16, 20, 24, 28, 32, 36, and 40, 44, 48. 48. Now we need to figure out up here. 6 times what equals 48? Let's skip count. 6, 12, 18, 24, 30, 36, and 42. Oh, I went too high. 36, right? Oh, we need to get to 48. Excuse me. 6, 12, 18, 24, 30, 36, and 42, 48. 8 fingers up. 8. That means we need to shade 8 pieces. But we can also remember when we were like, 6 times what is 12? 6, 12. 6 times 2. And then we did the same thing up here. Times 2 is 8. Now we're going to shade it. How many slices do we shade? 8. 8 twelfths. This is the trickiest one of them all, okay? So practice this one. So you take this fraction, the original fraction, and then you have to make an equivalent fraction with 12 in the denominator because there's 12 pieces, which represents our whole. And then we have to figure out the missing piece, okay? All right, let's do number 10. Carla writes a fraction that is equivalent to 3/5 by multiplying the numerator and denominator by 3. What equivalent fraction does she write? All you have to do is put 3/5 times, what did she multiply it by? A fraction with the numerator and denominator, that is 3. By multiplying the numerator and denominator by 3. So what do? What do you think, V-Bug? What should go in this fraction? What should go on the top and the bottom?
I think 3.
Yeah. 3 and 3. Because
And
Carla writes a fraction that is equivalent to 3/5 by multiplying the numerator and denominator. So we're multiplying the numerator and denominator by 3. Then we have to multiply. 3 times 3 is what?
9.
5 times 3 is what?
15.
Good. So that is our answer, and I'm going to box it to show that that's my final answer.
Oh.
All right. Listen. This one wants to be scary because it's long, right? But let's read it. Yuri has 2 same-size circles that are divided into different numbers of equal-sized parts, so fractions. He shades 1/5 of the first circle. The second circle has 3 times as many parts as the first circle. Yuri shades an equivalent fraction of the second circle. What fraction of the second circle does Yuri shade? Ooh, so think about it. He shades 1/5. So let's write 1/5 on the bottom. Oh, my battery's gonna die. Oop, I gotta charge.
I thought you were about to say that. The video was over.
Oh gosh, I hope it is. It's recording. Whew.
Remember last time?
Yeah.
Okay. Okay, so we have 1/5. That's what he shades on the first circle. He shades 1/5 of the first circle. The second circle has 3 times as many parts as the first circle. What are the parts represented? We have part over whole. The 1 is our part. So we need to multiply, or it's going to be 3 times as big. So the part is 3 times as big. Times as big. That means multiply. What's 1 times 3?
3.
Good. Now, we need to cross multiply because we need to figure out this bottom piece. 5 times 3 is what? 15. Then we need to figure out what would go down here. 1 times what is 15? 1 times what is 15? 1 times blank equals 15.
Oh, I know.
What?
5?
No, what's 1 times 5?
What's 5?
Yeah, so 1 times what is 15? If 1 times 5 is 5, 1 times blank is 15. What's the blank, Vanessa?
5? 1.
1 times 15 is
3.
15.
Wait.
Always.
1 times 1?
No, 1 times 15 is 15.
Oh, my God.
Because we went here. 5 times 3 is 15. And then we went here. 1 times 5 is 15. So 1/5 is equal to 3/15. Okay? We're making equivalent fractions.
You know you don't have to do the lines, right?
I know, I just did it for now. Like I said in class, we're trying to move away from doing that, but I just wanted to show you. Okay, now, write the fractions in order from greatest to least. This is interesting. So, we need to put them in order from the biggest, the greatest, to the smallest, the least. So we need to compare, and we can use cross multiplication to do that. So, let's compare 2/5 and 3/10. So we're going to write it up here. 2/5 and 3/10. Let's figure out which one is larger. 10 times 2, 10, 20. 5 times 3, 5, 10, 15. That means 2/5 is greater than 3/10. Okay, so good. So we see it's already in front of 3/10, right? Now we have to compare 1/2 with the bigger number. So let's put a B next to the 2/5. Now we're going to compare 1/2 and 2/5. 2/5 and 1/2. Let's find out which one is larger. 2 times 5 is 5. 2 times 2 is 4. That means what is bigger? 1/2. So 1/2 is the greatest. Then 2/5. And then 3/10. That is the order from from greatest to least. Okay? So it's like you do matches. So the first match was 2/5 and 3/10. And we decided that 2/5 was bigger. We found out 2/5 was bigger by cross multiplying. Then up next was 1/2. So we compared 2/5 and 1/2. And 1/2 was bigger. So we know 1/2 is the greatest then 2/5, then 3/10, okay? Okay. We have one more piece left. Emily uses this visual model to show an equivalent fraction for 1/4. How many boxes does Emily shade on the visual model to show an equivalent fraction of 1/4? Again, just like we did here, we're going to make a comparison. So 1/4. And now we have to create a fraction, an equivalent fraction to 1/4, but we're going to use this picture to help us fill out the other fraction. So I see how many parts, right? For my whole. 1, 2, 3, 4, 5, 6, 7, 8. What I'm missing is my numerator. So I can cross multiply. 8 times 1 is 8. I want an 8 over here too. 4 times what is 8? Let's skip count. 4, 8, 2. 4 times 2 is 8. That makes them equivalent. So how many boxes does Emily shade on the visual model to show an equivalent fraction of 1/4? How many should she shade? The top piece. So I'm even going to shade it. 2/8. And she needs to shade 2 boxes. Okay? Work through these over and over again to understand them. All right, let's go to the bottom piece. Place an X in the table if each fraction is equivalent or not equivalent to 1/4. Nice. So what we're going to do, we're going to set up cross multiplication. So 3/12 and 1/4. Let's see if they're equivalent. If they're equivalent, we put an equal sign. What's 4 times 3? 4 times 3.
3, 6, 9, 12.
Good. 12. What's 12 times 1, Vanessa?
12.
Good. So are they equal? Yes. So we check equivalent. Equivalent means equal. Now we're up to 5/10. And we're comparing it with 1/4. 4 times 5. Let's skip count. 4, 8,
12,
16, 20.
20.
That's it. Nope, you stop once you have 5 fingers up. 10 times 1 is 10. Are those equal? No, they are not equivalent. 20 and 10. Is that
No.
equivalent? No. Not equivalent. All right, let's go to the last one. 6/12. Listen, if you have the same denominator but different numerators, that means you're not equivalent. But let's just do the butterfly method to test. 3/12 and 6/12. Let's skip count. So we're going to skip count by 6 until we reach 12. Or, look at this. We could do long multiplication. 6 times 2, 12. The one up. 6 times 1 is 6 plus 7. But let's check and see if we are correct. 6, 12, 18, 24, 30, 36, and 42, 48, 54, 60, 66, 72. That's a 12. Oh my gosh. And is 12 times 3 going to be larger than 12 times 6 or equal? No, but let's just show you. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. Those are not equal, not equivalent. So listen, math test tomorrow. Do not just watch this once and call it a night. Watch this over and over. Work out every single problem multiple times, okay? Really try to get it. Come to me in the morning during tutoring if you need a little extra help. You also have a spelling test tomorrow. So study your spelling words. You got to study math and spelling tonight. Read 20 minutes and log it. And that's it. All right. I'll see you guys. Bye.
Bye-bye.